Hello, my name is Nikki Neal, and I'm a senior manager here at AWS on the Government Regions Business Development and Go-to-Market team, primarily the part of our team that's responsible for executing within the federal, civilian, and national security space. And I'm thrilled today to kick off our session, Modernizing Engagement for the 2020 U.S. Census. This is an historic moment for the United States and the U.S. Census Bureau, and that this is the first time that residents in the United States have been able to respond to the U.S. Census count on the internet through their Internet Self-Response Survey. At AWS, we are honored to have been a part of this team, working very closely with both the U.S. Census Bureau, as well as their lead systems integrator, TRex Solutions, and other partners in bringing this program and this mission to a successful close. So you may be aware of the fact that in November of 2018, AWS launched its second GovCloud region, GovCloud US East, and made it publicly available to customers. Many of our customers within the U.S. government, as well as the regulated industry space, run mission-critical applications and require two AWS GovCloud regions primarily for disaster recovery and continuity of operations for mission-critical programs. U.S. Census Bureau was actually one of the customers that we worked very closely with, who was very influential in driving the requirement as well as the timeline for the launch of our second GovCloud region in order to support this very critical mission. And obviously, given the critical nature of their set of applications, the fact that it has to run 24/7, in many cases with no downtime, and some applications virtually no downtime. There were several different elements to consider as this customer decided to deploy a multi-region architecture using a hot deployment. One certainly being the scale of the operation in itself, data durability with their cross-region data collection, as well as replication, data security, and of course the sensitivity of the information that was being captured amongst those that responded made that a top requirement. So without further ado, I'm pleased to introduce you to Michael Thiem, who's the Assistant Director for the Decennial Census Program for the U.S. Census Bureau, who will be sharing a bit more with you about the Census 2020 program and the evolution of some of the technologies that were used and deployment methods leading up to this point, as well as Utpal Amin, who is a chief engineer at TRex Solutions and was the deputy chief engineer for the technical integration team for the 2020 program for Census Bureau. And with that, I will hand it over to Michael. Thank you.
Hello, my name is Michael Thiem. I'm the Assistant Director for the Decennial Census Program. I'm for Systems and Contracts, and I'm very excited to be here at AWS reInvent to talk about the 2020 U.S. Census. I think it's actually very exciting this year because we had so many challenges this year, and one of the big success stories is technology that we used for the 2020 census, and we're going to talk a lot about that. We're going to talk about how we modernize the census. I'm going to give you a brief history of the census. I'm going to talk about how we use technology in 2020. And my friend Uptal is going to talk about the census case study and our architecture. We're going to talk about the resiliency and the scalability using AWS. And finally, we're just going to hit on how it was all successfully put together and made successful by the technology. But let me start with a little bit of history. One of the things about the census that people may not realize is that we have a long history of technology and actually testing technology and developing technology within the Census Bureau that goes back hundreds of years, actually. The first census was in 1790. By the time we got to, and by the way, the 2020 census is the 24th census of the United States. But in 1790, we had U.S. Marshals going around with pencil and paper. By 1880, we actually, in 1850, the first mechanical calculator was invented, but by 1880, we were to the point where it only took us about 8 years to tabulate the census that we did for about 50 million residents of the United States in the 1880 census. But by 1890, we figured out a way to make a mechanical tabulation machine. And interesting fact about census, the person who invented that was a census employee. His name was Herman Holrith. And you may remember him because he actually used the punch card that essentially became one of the staples of computer science and one of the beginning pieces of computer science that we know about today. Another interesting fact is that Herman Holrith was one of the first founding people of a company we now know as IBM, International Business Machines. Fast forward to the 1960s and 50s and 60s, the Census Bureau was really the first federal agency to put in place the UNIVAC-1 computer, one of the first major computers in the world. And we used that computer for the 1960 census tabulation for 189 million people back then. And then fast forward to today. Every census before today has been a paper operation. In 2020, we're going to talk about the modernization we did with IT, but particularly we're going to talk about how the cloud helped us do that. As you can see on this slide, we have roughly 334 million. We're still waiting for the answer. 148 million households and a staff of about 600,000 people in the field to do the census, which is actually the largest peacetime effort that the federal government makes. So it's a bigger thing than people might realize. With the help that the cloud gave us, we went from 8 years back in 1880 to just months to do the processing and tabulation for the 2020 census. Moving on, so how is technology being used for the 2020 census? First, I want to give you an overview of what we do in a census. It's very important to kind of understand the foundation that we have to build. And the first thing we do is establish where to count. Our census is a household-based census, meaning that once we have every household in the nation, that's how we base our count. That's the frame for the count that we make of the population of our country. That process to get that frame is an ongoing year-by-year process. People wonder what the census does throughout the decade. That's one of the major things we do is we make sure that our address list is correct. After we have that, we motivate people to respond. We do that through advertising, through partnership with communities and local leaders and governments. Then we get into the actual running of the census, which is having people respond to the census. And we know from hundreds of years of experience that the best response is a self-response to the census. Self-response meaning that I actually fill out my own census form. And in this census, for the first time, I was able to fill that out online on the web. However, we don't always get everybody to, as you can imagine, everybody to respond to the census. Some percentage of the population just is not interested in self-responding. So what we have to do is we send those hundreds of thousands of people I was just talking about out to knock on their doors and ask them to respond right there at the door. That's called our non-response follow-up, and that really is the biggest part of the census. Finally, we take the results of that and we actually tabulate those results and deliver them to the President and to Congress. So what are the innovation areas that we actually dealt with the census? When I talked about that address-based census and that address list, we actually re-engineered this time our what we call address canvassing. We used to drive and walk down every road and street in the United States, 4.2 million miles of roads, 6.8 million kilometers of roads. And that is a very labor-intensive, time-intensive, and cost-intensive operation. What we did this time is for over 60% of that address canvassing operation, we were able to do it on systems in the office. We did not have to send people out to well-established neighborhoods based on things like aerial imagery, comparing the aerial imagery from previous censuses, previous years, previous government records, and so on for the localities that worked with us to actually get that address list up to date. So that was one of the first innovations, is re-engineering that whole thing to make it an in-office operation. The second innovation is we optimize self-response. Now this, I like to say, is meeting the respondent where they are. So in the 2020 census, you could respond on your iPhone or your cell phone or your Android device. You could respond on a PC in your home. You could still respond on paper if you wanted to, and a lot of people did that. But you could even call us on the phone. So wherever you are, whatever you were doing, the 2020 census, through technology, met you where you were so that you could respond. And so we optimized that process. We also, well, I'll talk about optimization in a minute too. We did a lot with using people, the records that we have for people in the United States from other sources, what we call administrative records. These are records maybe perhaps in government records or local records, any kinds of records that would help us to see if we could avoid sending people actually to doors if we already had good information about those households. And then finally, we re-engineered our field operations. The most expensive part of the census is sending those people to the doors, and we were able to use technology and the cloud essentially to route people more efficiently to the doors of every household and make the whole census operation for non-response follow-up technology-driven and data-driven and efficiency-driven. So that's the big stuff that we did for the census in terms of our big innovation areas. Let me talk a little bit about census by the numbers. As you can see on this slide, we actually had 52 critical IT systems for the census of 2020 census. Fully 20 of those were in the cloud. We had over 7,000 server instances in the cloud. We were in 2 regions, West and East, for the GovCloud. When we actually got ready to do the census, particularly on our online response mode, we tested that so that we actually could support 1.2 million concurrent users at our peak. Now, we never actually reached that peak, but we actually were at a place where we could have if that had happened. We supported 260 regional census offices with 17,000 workers in those offices. As I said before, we had actually over 600,000 people that were invited to actually work on the census. We had 500,000 that were hired, 148 million households again, 334 million residents. And really, one of the most impressive things compared to previous censuses is that we essentially stood all this up in the cloud in 18 months from the time that we started to the time that it was up and running. So I am now going to turn it over to my friend Uptal, who's going to talk more and in depth about the technology of the census and some of the particular things that we use to do that. And thank you very much. Uptal?
Thanks, Michael. My name is Utpal Amin, and I'm the Chief Engineer at TRex. I'm going to provide more details on how technology was used during the 2020 census. TRex, as the prime contractor for technical integration program, along with AWS, provided the highly scalable cloud infrastructure for the 2020 census. You may know TRex since recently Team TRex won the AWS Game Day event for public sector, where we did a live application migration scenario using 20 AWS services. Throughout the presentation, I'm going to use Internet Self-Response, an acronym of ISR. ISR, or Internet Self-Response, was developed using service identification, service design, service transition, and service operations. We'll look at each of those phases now. During service identification, it was determined that we needed a robust website to collect census information over the internet with high level of confidence that it will perform with fast response time under peak load without any security compromises. Website needed to be with multiple language support and had to be responsive so that US public can access it from various devices, as well as it had to be 508 compliant. During service design and service transition, emphasis was placed on 2 main features, resiliency and scaling. For risk mitigation purposes, the site was implemented using 2 different teams, using 2 different technology stacks, but both of those were implemented in AWS. Since there was only one cloud service provider, we needed to deploy it across 2 regions, AWS GovCloud East and West, and within each regions, also across all of the availability zones. Let's look at the ISR solution in detail. The ISR solution was made of 3 layers: at the edge, MTIPS, and the application layer. The edge layer was implemented using Akamai as a service. Akamai provided the content delivery network, but along with that, it also provided web application firewalls, protection against denial of service, whitelisting, blacklisting, as well as various other Akamai security services. The AMP-TIPS was implemented by Census at the two separate data centers, one in Bowie, Maryland, and one in Phoenix, Arizona. Both of those data centers had a 40 gig incoming traffic from the edge. The implementation of AMP-TIPS used two tiers of F5. The first tier of F5 provided global load balancing, while the second layer provided web application firewall and then connection into the AWS. The connection into AWS was done using direct connect into both regions. The application was deployed across, again, all three availability zones in the two regions. The data was replicated between the regions using the features like DynamoDB global tables. Let's look at some of the other AWS services that were used for the implementation. Besides DynamoDB, which was used to store census ID and replicate it across the regions, we also used EC2s and RDSs for compute as well as the data storage. The load was balanced using elastic load balancers to various EC2s and the RDSs. We also used AWS Lambda functions to take the application data that was collected with the ISR application and provide it to the downstream systems. We also used AWS S3 to store various map data that Michael talked about, and also stored various simulated data where we used it for testing purposes, as well as various backups of the systems. We had over 4 petabytes worth of data just for the census operations. Besides these key services, we also used various other AWS services as highlighted on the screen. Let me give you a couple of examples. The AWS Snowball was used to transfer the audio recordings from our call center that Michael talked about back to Census. We also used AWS Cost Explorer to look at various aspects of the cost, especially when we were ramping up and down, and so that we can attribute the cost to each of the systems, to each of the environments, to each of the services. And we are able to control the budgets and be able to come within budget. For scaling purposes, both our primary application as well as the secondary application used two different technologies. Primary ISR used AWS's native feature of auto-scaling, versus our secondary application used clustering. However, both of these applications, one of the key things we implemented was the contain and sustain strategy. Let me get a little bit more details about it. For the contain and sustain, in case if there was any incidents, including the security incidents, we were able to isolate it to a particular instance and then basically take it out of the auto-scaling group. Once that particular instance was taken out, it was replaced by another instance as part of the auto-scaling. However, we did keep the impacted instance because we could do forensics later on that particular instance. The whole aspect of this was all automated and was driven through thresholds and triggers. We actually practiced this multiple scenarios so that during operations, there will be a flawless implementation. Now let's talk a little bit more about service transition. During service transition, we practiced a lot of failover scenarios, as well as we validated the production environment using production validation things. Let's look into some of the failover scenarios. During this, one of the failover scenario is the regional failover. In case if there was a regional failover, either at the AMP-TIPS layer or either at the AWS layer, then the traffic from the edge would be routed to the second side of the AMP-TIPS and the AWS cloud. This was all done automatically by the Akamai services, and it was done within sub-seconds. In case if there was an application failover, we would switch from our primary application that was designed by one team to the secondary application. This would involve decisions by the census leadership and would take a little bit of time. However, we had also practiced this particular scenario. Let me talk about a complex failover scenario. In case if there are failures both on the various components on the east as well as the west. So in case if the AMTIPS on one side was failed, plus there were issues with the direct connect on the AWS, then we would do a complex rerouting from the edge on one region to the AMTIPS on the second region, back to the AWS on the different region. We had a scenario during operations when there was a fiber cut on the East Coast, which made us go all our traffic to the Western region. And then we had, as Michael talked about, wildfires coming up on the West Coast, which was threatening the AWS regions, West region. We did not have to go into this particular complex failover. However, we were very prepared for this scenario and had practiced this particular aspects of it. Now let's talk about the scaling. We had done a lot of performance and scalability testing to make sure that we can support up to 1.2 million concurrent users coming onto the internet website. We also determined what was the overall breaking point, and we were able to test all the way up to the 2.4 million concurrent users. The performance and scalability testing was done within 4 phases. During the phase 1, we reviewed the architecture and developed a lot of demand models that told us how is the site going to be utilized. Depending on the mailing that were sent out to each of the public, people would respond, and then we plotted that across various days. During phase 2, we tested the site on an individual basis for those peak loads. During phase 3, we actually not tested the site along with the other downstream systems. So not only we made sure that we are able to collect the responses, but we are also able to take that information and pass it on to the downstream systems. And then during phase 4, we did a lot of chaos testing and the failover testing while we are doing performance testing. So that way we were sure that the site would perform adequately even during failure. Throughout the process, we used various types of metrics, including number of defects, number of test cases that were implemented, as well as various timelines. We also involved various AWS teams, including the AWS architectural team, AWS service teams, as well as capacity management and reservations of various capacity. Because of all of this, we went into the ISR operations with a high confidence that the site will perform to meet our scalability goals. During operations, we wanted to make sure there was nothing happening. So each and every part of the service component were monitored using our Splunk infrastructure. We also used Splunk ITSI as the aggregation for systems of systems and present that metrics as a dashboard. This dashboard was used by all the stakeholders. Let me show you the dashboard. So this was the primary ISR dashboard, or Internet Self-Response dashboard. It showed us how many users were taking the survey at a given point in time and how it was flowing across various different systems, various different nodes and network into our primary ISR application. It also showed how the information that was collected flowed from our primary application into the secondary applications and then onto the backend systems. So overall, we had a very successful 2020 census. Despite of the COVID, we were able to collect over 53% of the responses via the internet, as Michael talked about. In the 18 months, we were able to go from 0 to fully implementing the site and be ready to take on the challenges. This was achieved because of the relentless automation that we did in implementation of these aspects of it. One of the biggest automation was done during our DevSecOps, and that allowed us to do continuous deployments to the sites. Because of that, we had over 200 days of site implementation operations without a single second of downtime. All of this was also very secure because we implemented active cyber defense throughout the implementation. Let me turn this over to Michael so he can talk about the successes from his perspective.
Thank you very much, Uptal. I want to wrap this up with some key success factors that we had for the 2020 census. As you may have heard on the news, we achieved a national enumeration rate of 99.98%, which is the highest we have recorded for a census. Automation and increased use of technology, like the enumerator use of our iPhones for case routing optimization, contributed to a 90% increase in enumerator productivity over our previous census. This is a huge cost saver. Online training. We used to actually do our training with what we called verbatim training. We would invite people to libraries and other public venues and essentially read from a script all the training that an enumerator would get to go into the field. We, through technology this time, we were able to put that training online, make it, I think, much more interesting to watch and to understand and more effective as a training tool and faster for people to get prepared for the census. Data collection completed in a challenging environment. We have never had a census, I think, that had more challenges than the 2020 census. From COVID to wildfires to hurricanes, the most busy hurricane season on record, to even public upset over issues in the public arena. There was nothing that wasn't thrown at the 2020 census, and I think the technology, and particularly the cloud, our ability to expand and contract when we needed to stop and start when we needed to, made the 2020 census agile enough to be successful in that challenging environment. Finally, we actually we got 79 million households to respond on the internet. Which is a huge cost saver when you compare to the cost of actually sending someone out to a household for that. Just some quick quotes from our director and from some magazines. Despite the pandemic, the 2020 census self-response has been a tremendous success. That's 79 million people I'm talking about. And let me actually also say, as Uptal said, we did not have 1 second of downtime on our internet self-response. The technology in that respect and in many respects was flawless. Our response system, as I said, has not had a single minute, I like to say a single second of downtime since we first invited people to respond online back in March of 2020. So with that, I want to thank you for listening and thank you for responding to the 2020 census, and we'll see you in 2030.
Thank you so much, Michael and Utpal. That was extremely valuable information. I think certainly our audience here enjoyed hearing what the Census Bureau had to share and understand a bit more about several of the elements that factored into some of the key architectural decisions that were made, particularly as it related to scalability as well as resiliency. And of course, we want to thank all of you who are watching that are U.S. Residents who responded to the U.S. Census Bureau, helping to make the data collection portion of this program a success for the U.S. government. And we encourage you moving forward to please make sure that you continue to check us out on the AWS Public Sector blog, as well as the GovCloud landing page and GovCloud What's New. There's, as I mentioned earlier, there are several different aspects to this program. It was very complex. That's something that both Michael and Utpal also touched on. And so we'll be coming to you in in several months, over the next several months rather, with additional blog posts and other technical materials highlighting other aspects of this program. Thank you for watching and enjoy the rest of your summit.